Now let's see the question, the first question. Examine the continuity of the function f of x equals 2x square minus 1 at x is equal to 3. So, as we have discussed, when do we say that the function is continuous? When limit x tends to a f of x equals f of a. I am just writing this to make you recall what we had discussed. So, the function is said to be continuous if limit x tends to a f of x is equal to f of a. Now, what is limit x tends to a f of x? Here, this is same as limit x tends to 3 of f of x. Right? Here we are checking for the continuity at x is equal to 3. So, limit x tends to 3 f of x. This is equal to what? Limit x tends to 3 of, what is f of x value? 2x square minus 1. As the value of x tends to 3, what is the value of the function tending to? It is not equal to, children, as I always say, it is tending to. To which value does this function tends to? That is 2 into 3 square minus 1. That is 2 into 9 minus 1. Sorry, minus 1, which is 18 minus 1, which is 17. Right? What is f of a? What is f of a meaning? f of 3. f of 3 is also 2 into 3 square minus 1, which is 17. So what can you say? Limit x tends to 3 f of x is equal to f of 3. Therefore, f is continuous. It is very simple, right? To check whether the function is continuous at a point where x is equal to 3. So I have limit x tends to 3 f of x. As the value of x tends to 3, the value of the function is tending to 17. And this is same as the value of the function at x is equal to 3. So that the function is continuous. Okay. Now let's see the second question. Check the continuity of f of x, which is equal to 1 by x minus 5. It is given x is not equal to 5. So what does the question say? We are asked to check the continuity of this function f of x. f of x given f of x is equal to 1 by x minus 5, and it is also given that x is not equal to 5. What happens when x is equal to 5? The function becomes undefined. That is 1 by 5 minus 5, 1 by 0 it comes. The function is not defined. So the domain of this function, I can write this as r minus set 5. Right? R minus set 5. Now let me take any arbitrary value, say c. So c is an arbitrary value. What do you mean by arbitrary value? If you look at arbitrary values, any value that belongs to the domain of the function. C is now belonging to the domain of the function. Now, what I am going to check is, what about the continuity at this particular point C? This C can be any value. This C can be any value that is lying inside the domain of the function. So I am taking any arbitrary value C that belongs to the domain of the function, and I am going to check for the continuity at that point C. Okay, so now to check for the continuity, what do I must check for? Limit x tends to C f of x is equal to f of C or not. This is what I need to check whether this statement is true. Limit x tends to C f of x is equal to f of C or not. So now let me see. Limit x tends to C f of x. What is that? Limit x tends to C. C is what? C is any value that belonging to the domain of the function. What is f of x value? 1 by x minus 5. Right? What is this value? As the value of x tends to C, this value becomes 1 by C minus 5. Right? 1 by C minus 5. Now, what is f of C? F of C. From there, I get it as 1 by C minus 5. Now you see that limit x tends to c f of x, where c is any arbitrary value. What do you mean by arbitrary value? C can be 5, C cannot be 5, C can be 1, C can be 2, C can be 3, C can be negative 5, negative 5 of course. C can be any other value that is not 5. Right? So, any value that belongs to the domain of the function, C can be any value that belongs to the domain of the function. I am not taking a specific value, but it is an arbitrary value, any value. Whichever value that you want to give that belongs to the domain of the function, the value C can be taken with that value. So, you see that limit x tends to c f of x is equal to f of c. So, what do you conclude? This implies f is continuous, where continuous in the domain that is given. So, we are asked to check for the continuity of f of x where x is not equal to 5. So, I have taken the domain as set R minus set 5 because it is given. Now, I have seen that the limit x tends to c f of x is equal to f of c. For any value c which belongs to the domain of the function, this is true. This statement is true. Okay. So, I have seen that f is continuous. So, that is what the second question deals with. Now, let's move on to the third question. Now, see the question. Is the function defined by f of x equals x for the values of x less than or equal to 1 and 5 for the value of x greater than 1 is continuous at x is equal to 0, x is equal to 1 and x is equal to 2. So, here we are asked to check whether the function is defined, that is whether the function is continuous at x is equal to 0, x is equal to 1 and x is equal to 2. Now, let me draw a number line. So, here I have 0, here I have 1, here I have 2. Now, x is equal to 1 is the place or is the point where the function is having two different values. On the left of 1, the function is having the value x, and on the right of 1, the function is having the value 5. So, what is the value of the function when x is equal to 0? What is the value of the function when x is equal to 0? That is when x is less than or equal to 1. That is, from here I am breaking it. Okay, from here I am breaking it. From this 1 to this side the value of the function is 5 and towards this side the value of the function is x. Right? Now, 4. To check whether the function is continuous at x is equal to 0, limit x tends to 0 f of x must be equal to what? F of 0. This is what you need to check for. Right? Now I am going to check whether limit x tends to 0 f of x is equal to f of 0 or not. Now, what is limit x tends to 0 of f of x? As the value of the function tends from the left hand side to 0 or from the right hand side to 0, the function value is what? X. Right? Are you understanding or are you following what I am trying to tell you? As the value of x tends to 0 from the left of 0 as well as from the right of 0. I am not telling about from this extreme right. Just in the neighborhood of 0. I use the term neighborhood. That is a little bit of this side. 0 minus and 0 minus here, 0 plus here. As the value of f of x tends to 0 from the left, that is 0 minus. What is the function's value? X. Here, if it is from the left or it is from the right, the function's value is what? X. So, what do I write? Limit x tends to 0 of x. What is the value? 0. At f of 0, what is the value? F of 0. X is equal to 0 is coming here, right? Where it is x. F of x. X is equal to x. What is x when x is equal to 0? It is 0. So, isn't this true? Isn't that true? Yes, that means the function is having the value 0 at x is equal to 0, as well as the limit x tends to 0 for this function f of x also gives you the value 0. That means our continuity exists, or the function is continuous at x is equal to 0. So I write f is continuous at x is equal to 0. Now checking for continuity at x is equal to 1. Checking for continuity at x is equal to 1 means what? Limit x tends to 1 f of x must be equal to f of 1. This is what you need to check. I am just writing this for you to keep in mind what is that we need to check. Okay. So now when we consider the point 1, is the function same on the left and on the right? No. Isn't it? So that I need to check for limit x tends to 1 minus f of x first. That is on the left side of 1. As the value of the function approaches 1 from the left side, that is what written as limit x tends to 1 minus. 1 minus means what? Lesser than 1. 1 minus f of x. This is limit x tends to 1 minus of, which is the function's value here on the left of 1. It is x. F of x value is x. Now as limit x tends to 1, what is the value of f of x here? X will become 1. As the value of x tends to 1 from the left hand side, the value of x is coming up to 1. Okay. Now what is f of 1 here? What is f of 1? F of 1 means the function is what? F of 1 is 1. Right? F of 1 is 1. Then limit x tends to 1 plus f of x. 1 plus f of x. 1 plus f of x means what? On the right hand side of 1. That means x value is greater than 1. X value is greater than 1. What is the function's value? 5. So I will write limit x tends to 1 plus of 5, which is 5. Here x tends to 1. F of 1 means what? F of x is equal to 1. The function value is x. So f of 1 is equal to 1. So what do I get here? Limit x tends to 1 minus f of x not equal to limit x tends to 1 plus of f of x. We needn't have to write about f of 1 because this itself does not exist, right? Therefore f is not continuous. F is not continuous at x is equal to 1, or I say that the function f is discontinuous at x is equal to 1. One more thing children, one more time I am going to tell you the same thing. X is equal to 1. To check for continuity at x is equal to 1, I need to check for what? Limit x tends to 1 f of x is equal to f of 1 or not. Now here when I check for limit x tends to 1 f of x, as the value of the function approaches 1 from the left hand side, the function value is different. When it comes from the right hand side, the function value is different. So I need to check for both, whether limit x tends to 1 f of x, 1 minus f of x, that is x is equal to 1 is what I am getting as x tends to. As the value of x tends to 1 minus from the left hand side, it is f of x value is x. So as the value of x tends to 1, this x becomes what? 1. Now limit x tends to 1 plus, that is adjacent to this 1, more than 1. What is the function's value? 5. So I have limit x tends to 1 plus f of x is equal to limit x tends to 1 plus of 5, which is again 5. Okay, so now we see that these are not the same. So the function is discontinuous. Now checking for limit at the point x is equal to 2. Right? Continuity when x is equal to 2. Now x is equal to 2 means what? As I have discussed for x is equal to 0, you will write it for x is equal to 2. 2 plus 2 minus, the function value is 5 itself, right? So I can just conclude by saying that limit x tends to 2 of f of x is equal to what? As the value of x tends to 2, value of the function is what? 5. At 2, the function is what? Function is what? 2 again. 5 again. The function as x tends to 2, f of, I shall write limit of x tends to 2f of x is equal to what? Limit x tends to 2 of, from both sides, what is the function's value? 5, which is equal to 5. As well as f of 2 is also equal to 5. F of 2 is also equal to 5 because here in this area where the value of x is greater than 1, the function value is 5. 2 is definitely a value that is greater than 1. What is the function's value? 5. Got it? So, I will get it as the function is again continuous at x is equal to 2. Okay. So, now we move on to the fourth question. Discuss the continuity of the function f of x is equal to modulus of x. What is f of x here? Modulus of x. Let us see f of x in detail. F of x is equal to mod x. How will I split this? It is minus x for the values of x less than 0 and x for the values of x greater than or equal to 0. Is it or not? We have already discussed modulus value of x. So, in order to check for the continuity of modulus of x, I take a value here minus x and x. Now, I am going to check it for what is the value, whether the function is continuous at x is equal to 0 or not. Because, see, for the value of x less than 0, now here to check whether the function is continuous for the value of x less than 0, because here you see on the number line, if you look at, this is 0, this is the value of x less than 0 and this is for the values of x greater than or equal to 0. So this is into two parts. One is x values is less than 0. Another one is x value is greater than 0 and x is equal to 0. These are the three cases that is coming under the session. Okay. So now when x is lesser than 0, let c be, I take c as an, c be any arbitrary value. Right? C be any arbitrary value that is less than 0. Okay, and less than 0, when x is less than 0, let C be any arbitrary value such that limit of x tends to c f of x will be what? Limit x tends to c of f of x. What is the value? Minus x, which is equal to minus of c. Right? Now, so limit x tends to c f of x for any values that is lesser than 0, I get it as minus of c. Now what about f of c here? What is f of c here in this function when the value of x is less than 0? It is minus of x. Now here I get it as minus of c. What does this implies to? This implies f is continuous when x is less than 0. So this case is over. Now when x is greater than 0, okay, when x is greater than 0, similarly I take any arbitrary value. Let c be any arbitrary value. Arbitrary value means what, children? Any value, not specifically given to be any value, but it can be any value. Some of you feels like to take 4, some of you feels like to take 5, any positive value. Okay, so let c be any arbitrary value, then limit x tends to c f of x, which is equal to limit x tends to c of, for any value of x greater than 0, x is greater than 0, what is the value of the function? X. So I have the function value is x. When I apply the limit, what will I get? I'll get it as c. Now, what is f of c here in this case? F of c is equal to, here, x is greater than 0, it is x again. So, f of c is equal to, f of x is equal to x. What is f of c? F of c will be equal to c again. This implies f is continuous when x is greater than 0. So, we have discussed for the values of x less than 0 and for the values of x greater than 0. Now, what is remaining? For the value of x is equal to 0. What happens when the value of x is equal to 0? Now let's discuss. Now see, as we have discussed it here, on the left hand side of 0, the value of the function is what? Minus of x, and on the right hand of 0, the right hand side of 0, you have the value of the function as x. Okay, so now here we need to check for both limit. Which limit? Left hand limit as well as right hand limit. So I check for left hand limit. Limit x tends to 0 minus f of x. 0 minus means what? Left hand side of 0 is equal to limit x tends to 0 minus. When it is less than 0, what is the function's value? Minus x. Fine. So it is minus of x. As the value of x tends to 0, what is this value of the function? This function's value will be equal to 0. It is x here. X value will tend to where? 0. Now, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. Now, this is the right hand limit when it comes from this side to this side. What is the function's value when the value of x is greater than 0? It is just x. Right? So I have x here. Now, as the value of x tends to 0, what will happen to this limit function? The x value will become what? 0. Right? What is f of 0? When x is equal to 0, the function value is x. So f of 0 is also equal to 0. So what can I say? F is continuous at x is equal to 0 also. So, ultimately, as the conclusion of this, the left hand side of x is 0, the right hand side of x is 0, limit value is 0, and at the point of x is equal to 0 is also 0. So the function is continuous at x is equal to 0. From the beginning to the end, I will conclude that the function is continuous. That is, our mode function is continuous everywhere. In the set of real numbers, when it is considered as the domain of the function, it is continuous everywhere in the set of real numbers. Well, now we come to the next question given. Discuss all point of discontinuity where the function is given by x cube minus 3 for the value of x less than or equal to 2 and x square plus 1 if x is greater than 2. Now let me represent this on the number line. We are asked here to find the point of discontinuity. So on the number line, if you look at, this is 2. This is for all the values of x less than 2. This side you have for all the values of x greater than 2. Less than or equal to 2 and greater than 2. What is the function's value? For the value of x less than 2, the function value is x cube minus 3. And for all values of x greater than 2 is the function value is x square plus 1. Right? Now, for all values of x less than 2, how did we prove all those? Check for continuity. How did we check for continuity? Or how did we prove that for all values that belongs to this particular interval continuity? That is, we considered let C be any arbitrary value. I repeat, let C be any arbitrary value less than or equal to 2. Less than or equal to 2. That is, C is a value that is less than or equal to 2. That means inside this interval lies what? Our C. So, limit x tends to C f of x is equal to what? Limit x tends to C of, that means for any value that is lying inside this interval. Limit x tends to C of, what is the function's value? X cube minus 3. Right? So, as the value of x tends to C, this becomes C cube minus 3. What about f of C? For any value of C lying inside this interval, f of C is equal to C cube minus 3. This implies limit x tends to C f of x is equal to f of C, and hence f is continuous in this interval or for all values of x less than or equal to 2. Therefore, f is continuous for all values for all x less than or equal to 2. Right? Now, checking for all values of x greater than 2. So, to check for all values of x greater than 2. Here, for all values of x less than or equal to 2. Fine. Let C be, again what? C be any arbitrary value. Arbitrary value greater than 2. Greater than 2. That means now my C is lying between this interval. Lying inside this interval. Right? I am not touching 2 for all values of C greater than 2. So, let C be any arbitrary value that is greater than 2. Then, limit x tends to C f of x. Now, the C is lying where? Here. Right? Limit x tends to C f of x is equal to limit x tends to C, or what is the function's value? X square plus 1. Substituting for x is equal to C here, what will I get? C square plus 1. Right? Now what is f of C for all values of x greater than 2? When you take any arbitrary value C, what is f of C? Again C square plus 1. So limit x tends to C f of x is equal to f of C for the value of C belonging to, or for all values of C that lies where? Here in this interval. For all values of C, that is for all values of x here greater than 2. So, for all, this is enough. Limit x tends to C, f of x is equal to f of C. So, here again the function is what? Continuous. Therefore, f is continuous for all x greater than 2. Now, let's discuss at x is equal to 2. Right? X is equal to 2. So here when we discuss, we need to check for both the limit. Which limit? The left hand limit as well as the right hand limit. As the value of x approaches to 2 for the function from the left hand side, as well as the value of the function approaches to from the right hand side. So I have limit x tends to 2 plus, I am checking for 2. It is a specific value. Limit x tends to 2 f of x from the right hand side. Right? So, what is the function's value? Limit x tends to 2 plus of x square plus 1. That is what? 2 square plus 1. What is the value? Which is 5. Right? Now, limit, I am checking for the left hand limit. 2 minus f of x, which is equal to limit x tends to 2 minus. When it is towards the left side, 2 minus means little lesser than 2. That means lesser than or equal to 2. That is the area. So what is that function that comes there? That is x cube minus 3. What do you get here on substitution? 2 cube minus 3. 2 cube is 8 minus 3, which is equal to 5 again. Right? Here, what is f of 2? What is f of 2? F of x is equal to 2. This is the function. That is 2 cube minus 3, which is again 5. So, what can I conclude from here? Limit x tends to 2 plus f of x is equal to limit x tends to 2 minus f of x is equal to f of 2. Therefore, the function is continuous. Where? In the entire interval in which it is defined. For all values of x less than 2, less than or equal to 2, for all values of x greater than 2, and for all values of x is equal to 2, the function is what? Continuous. Okay. Now, let's move into the next question. That is question number 6. Discuss the continuity of the function f given by f of x is equal to 3 in the interval 0 to 1. 4 in the interval 1 to 3, it is an open interval, and 5 in the interval 3 to 10. That means, let me now plot this on the number line. Now here I have 0, then I have 1, I have 3, I have 10. So from the number line I am taking only so much, right? After this 0, towards the left of 0 I needn't have to discuss, and after 10 also I have a need to discuss. I need to discuss only the values from 0 to 10, or the continuity of the function inside this interval. But the value of the functions are different, right? Now, thinking about the point 0, when x is equal to 0. Thinking of the continuity at x is equal to 0. Now here, left hand limit I needn't discuss because left hand limit is not specified in the question. I need to discuss only for the right hand limit. Let limit x tends to 0 plus f of x. This is equal to limit x tends to 0 plus. Here, what is the function's value? Here it is 3. Isn't it? It's inside 0 to 1, it is 3. Now, 1 to 3, it is 4. 3 to 10, it is 5. I'm just writing the function, value of the function there. Okay, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus of what? 3. Right? Because 0 to 3, the function's value is 3 here. So, what is the value? 3. What is f of 0 at x is equal to 0? The value of the function is 3. Right? Therefore, f is continuous at where x is equal to 0. Right? Now I am checking for 1. X is equal to 1. Checking the continuity for x is equal to 1. Now if you look at the left of 1 you have the value 3. The right of 1 you have the value 4. Now at 1 what is the value? 3 again. Because when x is less than or equal to 1, value of the function is 3 again. Okay, but here limit x tends to 1 minus f of x. What is the value there? Limit x tends to 1 minus, the function's value is 1 minus towards the left side, it is 3. Right? And limit x tends to 1 plus f of x, which is equal to what? Limit x tends to 1 plus. 1 plus means more than 1, which is 4. The value is what? 4. Got it? Now here, this is not equal to this. Therefore, f is discontinuous. Discontinuous at x is equal to 1. X is not continuous. That is what is called as discontinuous. N-O-S. Continuous at x is equal to 1. Now when x is equal to, the next value is what? 3. Right? When x is equal to 3. Limit of x tends to 3 minus f of x on the left hand side of 3. 3 minus lesser than that of 3 is equal to limit x tends to 3 minus of the value of the function is 4. So I have it as 4. 4 is a constant, right? At the same time, limit x tends to 3 plus f of x, which is equal to what? Limit x tends to 3 plus. Where do the function come? 3 plus this side. The value of the function is 5 here. Are they the same? No. Therefore, f is discontinuous. The f is discontinuous at x is equal to 3. Limit f is discontinuous at x is equal to 3. Now, what is next? So, 3 is also over. The next one is 10. Here, I needn't have to check for 10 plus because it is not defined in the function, or we are not at all interested in finding the value of the function there. So, we need to check only for what? The left hand limit of the function when x tends to 10. So, when x is equal to 10, what do you have? Limit x tends to 10 minus, because the function is attaining, or the function is taking the value 2. The value of the function is approaching 10 from the left only, from the right it is not specified. So f of x, limit x tends to 10 minus f of x. This is equal to limit x tends to 10 minus, when it is 10 minus over this side, what is the function's value? 5, which is equal to 5 again. What is f of, what do you have to find? F of 10. What is f of 10? At the value, when the value of the function x is equal to 10, what is the function's value? 5. Here, limit x tends to 10 f of x is equal to f of 10. This implies f is continuous. Right? F is continuous. So, which are the point of discontinuity? At x is equal to 1, the function is discontinuous, as well as x is equal to 3 also, the function is discontinuous. Now, here I didn't look into the interval where it is not specified in the question, whereas here the entire set R. The domain of the function was the entire set R. Here the domain of the function is from 0 to 10 only. So I need to discuss only that many values from the number line. I hope it is clear.